Assalamu alaikum dear students, I'm Engineer Abdul Basit and we are in week number 3, lecture 5 of the subject hydraulics. The topic we are going to discuss today in this tutorial is Newton's law of viscosity. Okay, so before going into the details of Newton's law of viscosity, let us discuss about viscosity first. Then later on in this lecture we will derive an equation of Newton's law of viscosity. We will discuss the statement of Newton's law of viscosity in detail, and also in the coming lecture of this week we will discuss the types of viscosities as well, like dynamic viscosity and kinematic viscosity, and we will also solve some simple problems related to that kinematic viscosity, dynamic viscosity, and on the Newton's law of viscosity as well. First of all, what is viscosity? This is quite simple and easy to understand it from this definition, that you can say the resistance to flow of a liquid is actually called viscosity. Okay, so resistance refers to any type of difficulty that occurs to the flow of some liquid. For example, we are having water and that is like poured in on the ground with having some gravity, and that tries to flow. Okay, so the water will flow easily as compared to honey. Why it is so? Because honey is having more viscosity and water is having less viscosity. In other words, you can say that honey is offering more resistance to the flow as compared to the water. So this is the property of liquids actually, that is particularly the resistance to the flow of that particular liquid. Okay, so as I mentioned that water is having less viscosity, that's why it is easy to flow, and there is less resistance offered to its flow, while the other thing, that is honey, is having more viscosity and it is comparatively difficult to flow. Okay, so that is actually in other words you can say that it is the measurement of the shear force that is being acted on the liquid layers to make it flow. Okay, so shear force is actually a force that is actually perpendicular, sorry, that is parallel to that of the surface of the object on which it is acting. Okay, so for example, we are having water and it is having different molecules. Okay, and these molecules are having formed layers. Okay, and these layers are sliding over each other when that water is flowing. Okay, so if these layers are easy to slide over each other, it means that the layers are having less resistance with each other and less shear force is required to slide that one layer of liquid over another layer. Okay, so that is a vice versa in case of honey, where the same there will be layers of the molecule of honey, as you can see in this picture. Okay, so these molecules will try to make a layer, and one layer will be placed over another layer and another layer and another layer. Okay, so then when these layers are sliding over each other, so some shear force will be acting on it. Okay, and that shear force is actually greater in case of honey. Okay, why? Because the layers are having are feeling more friction and more shear force will be required to move one layer over another layer. Okay, so here it is a definition. Viscosity is a measure of resistance to shape, deformation. It should not be confused with the density. So a density is something else. Okay, if you are looking at honey, so you will feel like it is a dense material as compared to water. It may be correct, but this is not the measurement of the viscosity. Okay, density is something else and viscosity is something else. To differentiate it, you must say that density is mass per unit volume. How much of the mass of honey or liquid, any liquid that may be water, is like put it in a sample in 1 unit volume. Okay, so that will be the density of honey, and that will be the density of water, in other words. But viscosity is defined differently, and it is a different phenomena. That is the resistance offered to the flow, or the resistance to shape deformation. Okay, so shape deformation is the same thing, that is flow. Lubricating oil is more viscous than water. Lubricating oil like mobile, that may be the case. Okay, that is a bit more viscous as compared to that of water, but it is less dense. Okay, the density of that lubricating oil is comparatively dense. So that doesn't mean that viscosity is inversely proportional to the density. It doesn't mean that. Okay, in some cases you may find it that the other liquids that are, for example, a liquid is more viscous, it will be more dense as well. Okay, in some cases you'll find it that a liquid is less dense, okay, but it is more viscous, so it may be vice versa. And mercury is very dense but has a low viscosity. Okay, the viscosity of non-Newtonian fluid will vary depending on the force applied over time or the amount of force. Okay, so non-Newtonian fluids refers to those fluids which do not follow the Newton's law of viscosity. What is Newton's law of viscosity? So let's do it right now. Here it is another example of that viscosity as well. Like for example, in that previous definition we have discussed this first para. Coming to this second para now. In order to have a better understanding of this term, let us take three bottles. We are having three bottles in which three different material liquids are placed, and one is a light liquid that may be alcohol, second is water, and the third is syrup. So alcohol is like having less viscosity or the least viscosity in these three types of liquids, and water is comparatively having more viscosity than alcohol, but it is having less viscosity than that syrup. Okay, any type of syrup that may be. So if we invert these three bottles at the same moment, we see that the alcohol bottle will be emptied first, then the water bottle will be emptied, and then the syrup bottle will be emptied. Okay, so why alcohol is rapidly emptying the bottle? Because it is having less viscosity and it is easily flowing out of the bottle, while the water is having comparatively more viscosity, so it takes some time, or time greater than that of alcohol. And that syrup is comparatively more viscous as compared to water and that alcohol, so that's why it is taking much time. Okay, then coming to Newton's law of viscosity, so the statement says that the shear on a layer of a fluid is directly proportional to the rate of shear strain. Okay, what does it mean by shear strain, and what is shear force? So here this is shear force. Okay, that is T, which is F divided by A, that force required that is parallel to the area. Okay, so that is force per unit area. Okay, in other words, you can say that the shear force are the force required to flow a liquid. Okay, that will be shear force, and that will be directly proportional to the velocities difference between the layers, and is inversely proportional to the distance between the layers. Okay, so how you can define it? Look at this diagram. You can see there is a layer on the top, and there is some spacing between the layers, and there is another layer of let's say water or any viscous material, a liquid. So the distance between these two layers is y. Okay, and v is the velocity of one layer, or you can say the average velocity of one layer and average velocity of the other layer. Okay, and then the difference between these two velocities is actually v, and a is the area. So you can say that the shear force required to slide this layer over this layer will be tau. Okay, T, here it is tau, can be pronounced as TU, tau. Okay, that is shear force. It is directly proportional to the velocity. So which velocity? this one, okay, and inversely proportion to this y, okay, this y. So you can say if velocity is more, then the shear force will be more shear force will be required. If you want to have more velocity of the water flowing or liquid flowing, then you should provide or more shear force. If the distance between the layer is more, then less shear force will be required. So it is inversely proportioned. Okay, so any liquid that is less viscous, it means that the liquid is having greater distances between these two layers of the liquid, okay, of the molecule. If we remove this sign of proportionality, so as a convention, we have to put some constant over here, and that constant is mu. Okay, so then this equation will become tau is equal to mu multiplied by v divided by y. Okay, what is mu actually? Mu is actually the constant of proportionality of viscosity, or coefficient of viscosity, and in other words we can say this is coefficient of absolute viscosity or coefficient of dynamic viscosity. So what does it mean by absolute viscosity, dynamic viscosity, and all these stuff? We'll discuss it later. Okay, so the equation will become like tau is equal to mu multiplied by v divided by y. So if we are having small change in the velocity and small distance between the layer, so then this equation can be written in this form, that is dv, differential of v and differential of y. Okay, so here the equation will be modified to this form by providing that tau value over here. If you want to find out that shear force, so this is shear stress. Okay, if you want to find out the shear force, so shear force is actually like a tau into area, or in other words you can say that this shear force, like for example, let me write it for you, that tau will be equal to force, that is P divided by area. Okay, so from this equation, if you want to find out this P, so how to do it? P will be equal to that tau multiplied by area. So you can see it here that tau multiplied by area is written. Okay, then this is mu multiplied by v divided by a, so this is tau. Okay, and this area is multiplied due to we want to find out that force. Okay, so then this equation will be modified to this form, or rearranged to this form, that is mu into area multiplied by v divided by y. Okay, so this is that equation that we can say that this is the mathematical form of the Newton's law of viscosity. Okay, so this can be considered as the effect of viscosity on motion will be like this. Okay, now coming to the units, so units for mu, this is actually coefficient of viscosity. So if you want to find it out, we will have to rearrange this equation to place this equation on one this term on one side of the equation, that is mu, and tau is taken to this side, and this is y divided by v now. Okay, so by rearranging the equation, mu will be equal to this thing. Now tau is equal to force per unit area, as I told you earlier, and y is the distance and v is the velocity. So the dimensions will be like force per unit area multiplied by length, this will be length divided by time. Okay, or you can say this will be equal to force is in newtons. Okay, so by rearranging this equation or having this calculation, this will be the final form, force into time divided by L square. This is L square, this is L, so L cube, one L will be cancelled with the other L, and this T will be taken to the denominator. So this will be the new form of the equation. So this force is having unit in newtons, okay, and this T is having unit in seconds, okay, and this L is having units in meters, so this is meter square. This is now the unit of viscosity we want to have. Okay, so in SI units we don't have that particular unit for it. It can be taken as Newton seconds per meter square. Okay, this can be like in the form of dimensions, that is force T L square. this can be the form of dimensions like that. But for to take it to SI units, we can take a bit modified form of this unit, that is poise. Okay, and what poise is equal to? Poise is equal to 0.1 Newton second per meter square. So the defined form will be equal to poise, which is 1 poise is equal to, or you, in other words, you can say this is actually equal to 1 divided by 10 multiplied by this Newton second per meter square. Okay, so this will be that modified form now. Okay, so let's discuss some numerical on this. Here you have got the units as well, and you have find out the mathematical form as well. And this is the statement that the shear stress on a layer on a layer of a fluid is directly proportional to the rate of shear strain. So rate of shear strain is actually that velocity, that change in the or you can say deformation in the shape. Okay, so if you apply more shear force, so more will be the shear strain. Okay, if you apply if you can say, in other words, you can say that for shear force, if you apply more shear force, so for a more area, more shear force will be required. For more velocity, more shear force will be required. But for distance apart, or you can say this distance, if it is more as compared to the other liquid, so then you will get that that less shear force over here. Okay, as this is inverse proportionality. So coming to that numericals now on that particular equation, if we have a flat plate of area 1.6 meters square is pulled with a velocity of 0.4 meter second. So this is the velocity. Okay, this is the area you need to have. Okay, this is relative to another plate located at a distance 0.25 meter. So this is actually that y for you. Okay, and find the force applied to maintain the speed if oil spreading the plate has a viscosity of 2 poise. So viscosity is given, that is 2 poise. So already I've told you 2 poise actually refers to 1 poise is actually 1 divided by 10 of Newton seconds per meter square. Okay, so dividing this by 10, you will get a new unit, that is Newton seconds per meter square. Okay, so 0.2 Newton meter per second square is equal to 2 poises. Okay, and the remaining unit will remain the same, but here it is in millimeters, so you have to convert it in meters, because the velocity is given in meters per second and area is also given in meters. So you have to convert, or you have to make these units the same. Okay, then the force we need to maintain that speed. The force required to maintain their speed is actually we need to determine. So force is here, mu into area into v divided by a. This is the equation we have taken from here, this equation. Okay, so here it is. By putting the values, mu is equal to 0.2, this is 1.6 is the area, and velocity is 0.4 from here. Okay, and 0.25 multiplied by 10 raised to power minus 3 is after the conversion of y to meters. Okay, this is that in meters distance between the layers. So putting all the values, you will get the force in newtons. Okay, so this is quite simple, no need to discuss it further. Here next example tells us two horizontal plates are placed 12.5 millimeter apart. Okay, so 12.5 millimeters apart refers to that y. Okay, y is given over here. The space between them being filled with oil viscosity of 14 poise. So 14 poise will be equal to 1.4 Newton second per meter square. Okay, calculate the shear stress in the oil. So here now not force is required, stress is required. Okay, so no need to put the area over here, the area should be divided over here to find tau. Okay, so then if the upper plate is moved with a velocity of 2.5 meter per second, so this is the velocity of the upper plate. Y is given, okay, that is in millimeter, so you had converted to meters. Mu is again 14 points divided by 10, you will get 1.4 newton seconds per meter square. Okay, this will be the form, and then you have to convert this. This V is given in meter per second, no need to convert it. By putting the value in this tau, you will get this mu is equal to 1.4 V divided by Y. So this will be the form. You will get this shear stress in the form of Newton per meter square, or in the form of force per unit area. Okay, so this is quite simple. You have to use the equation for force, or you have to use the equation for stress, and both are shear. Okay, coming to this next problem, that is about Newton's law of viscosity again. We are given with some data, that is a plate is 2.5 meter distance from each other, from a fixed plate. So here it is, 2.5 meter is the Y for you, moved at a distance at a 0.8 meter per second, so this is velocity for you. Okay, and required a force of 40 Newton per meter square, so this is the force for you. This is not force, okay, Newton per meter square is given, so this is tau actually, not force, this is actually tau. Okay, then this is shear stress actually, not shear force. To maintain the speed, find the viscosity of the oil between the plates. So you need to find out the viscosity now, you need to find out mu now. Okay, so Y is given, that is in meters, will be equal to this one, velocity is this much, and tau is given, that is 14 Newton per meter square. The thing we need to determine is mu, so rearrange this equation for mu. That will be, mu will be taken to the other side, and this will be the new form for us. Here it is. Okay, we need to find out mu, so mu will be equal to, after having that calculation of putting the value 0.125 newtons, again you will use the same equation. Okay, and if you want to take the unit to the poise, so then you have to multiply this with this thing with 1.2, as we are moving from a comparatively larger unit to a smaller unit. Okay, so that's all about the Newton's law of viscosity and some numericals on it, and what does it mean by viscosity. All the things I discussed over here. I hope you have got something new to learn from this tutorial. In the next lecture we will discuss about types of fluids and Newtonian fluids and non-Newtonian fluids, and also we will discuss kinematic and dynamic viscosities. Thank you very much for watching.